Most people think if a model has high accuracy, it's a good model. That sounds logical, but it's one of the biggest mistakes in data science. Because accuracy can lie. A model can show 95% accuracy and still be completely useless in the real world. The real question is not how accurate is the model. It's, is the model actually solving the problem? Think about this. Imagine you're building a fraud detection system, and only 1% of transactions are fraudulent. If your model simply predicts no fraud for everything, it will be 99% accurate. Sounds great on paper, but in reality, it's catching zero fraud. This is why accuracy alone is misleading. It doesn't tell you the full story. It hides what actually matters. That's where deeper evaluation comes in. Instead of just accuracy, you look at things like precision. How many predicted positives are actually correct in recall? How many real positives your model is catching? These concepts were formalized by researchers like Tom Fawcett, who worked on evaluation techniques like ROC curves to better understand model performance. The idea is simple. Don't just measure correctness, measure usefulness. In practical terms, model evaluation means choosing the right metrics based on the problem. In medical diagnosis, missing a disease is far more serious than a false alarm, so recall matters more. In spam detection, marking important emails as spam is costly, so precision matters more. There's no single best metric. The right metric depends on what you're trying to achieve. But here's the deeper issue. Evaluation is not just technical, it's strategic. You need to understand the cost of being wrong. What happens if the model makes a mistake? How does that affect the business or the user? A model that looks good in theory can fail badly if these factors are ignored. That's why real-world evaluation goes beyond numbers. It considers impact. Now, with AI systems becoming more complex, this problem becomes even bigger. Models can be highly accurate but still biased, unfair, or unreliable in certain situations. That's why evaluation now includes not just performance metrics, but also fairness, robustness, and consistency. Because a model that performs well overall but fails in critical cases is still a bad model. At the Learning Studio, the goal isn't just to teach you how to build models, it's to help you understand how to judge them properly. Because once you understand model evaluation, you stop chasing high accuracy and start focusing on real impact. And that's the difference between someone who runs models and someone who actually knows whether they work.